Hi, everybody. Welcome to the October 2025 SJAA imaging meeting. And tonight I'm going to be talking about KStars. My name's Murveit, and often I run this meeting, and tonight I'll be running it and presenting. So let me share my screen, and then, um, okay. Okay, let's see how this goes. So, whoops. We'll talk about KStars, but before we talk about KStars, um, a lot of times when people present in this meeting, they give their background on how they came to be presenting about astrophotography. So I thought I would do that too. So a little bit about me. First, how I got to California, I went to Berkeley, got a PhD there, got married, raised two kids, worked as an engineering researcher in speech recognition for 30 years, self-driving cars for about 10 years, and I was near retirement when this guy, Warren Craddock, who used the SkyX, gave an astrophotography talk at Waymo, just a lunchtime fun talk that we often had at Waymo. And that was sort of fascinating to me, like it blew my mind, as I'm sure when you show your friends your pictures, that you could take pictures like this. And I thought only, big, expensive professional telescopes could do that stuff. So I had that in the back of my mind. And let's see here. And then later that year, I went to Norway with my daughter Anna, and we were going to take pictures of an aurora. And here's one of the aurora pictures I took. And when I got back home, I mean, this doesn't have an aurora on it, but it was a pretty mountain on a night we were looking for auroras. And I noticed when I got back home, what is this little thing in the sky there? And lo and behold, I realized that's a picture of Andromeda. So, yes, this was a really dark place. And we were, north of the Arctic Circle, but that's my first astro picture. It was aurora picture. And in fact, there you go. Here's another one from that same evening, and you can see the Pleiades and also Andromeda in this picture. So that was my introduction to astrophotography. I got into it. I saw I could do these things with my normal Fuji DSLR and a tripod. This is an 8-second exposure in a dark sky. And then, so I got into it and I was talking to a friend about it, and he gave me an EQ5. He just had an EQ5 mount lying around in his garage that he'd never used. And he said, Here, my wife wants me to get rid of this. You can have it. And I went and I bought a Williams Optic refractor, and off I went. And I found this club called the SJAA. And I got the email of this guy named Glenn Newell. And I found out Glenn was giving these, Glenn and Jerry Joyce, in fact, were giving um, we're holding these outings in a place called Little Uvas. I guess we're looking for a replacement now for Glenn to do that. I don't know if one's been found, but to uh, go there. So I went. I signed up for the SJAA. Paid my $25. May have even added a donation, and went to Little Uvas. And Glenn there told me he would teach me how to do astrophotography. So I show up there with my EQ5 and my Williams optics, and I cannot get it to work. I forget what kind of software I was using, but I just couldn't. But of course, Glenn had a spare setup, as he often did, waiting for people who had problems. And he showed me how to use Sequence Generator Pro and pointed it over there at, and look at the picture. And so that's my first sort of, pro equipment, whatever you want to call our equipment, not pro, but amateur equipment, astrophotograph. Now, it wasn't all, smooth sailing, let's say, at that point. I tried to do this on my own. I got a mono camera, an ASI 1600, and I got some monochrome filters, RGB filters, and I decided I would go and, take pictures on my own without Glenn mentoring me. And and this is, a story, of things that can go wrong. I got these RGB filters. I figured, this one was reddish and this one was greenish and this one was bluish. I put it in my camera. I took pictures of the sky, and I never got colors that other people uh, found. Like my pictures were always quite different than everybody else's. And then I discovered, you know, in fact, this purplish one was the green filter. I was looking at reflected light. My window was open when I mounted the filters, and light comes off your window, bounces off it into your eye. But in fact, if you look through the filter, it was green. And and so I had my filters in all wrong, and had very strange pictures my first few months. But eventually I got my act together, and there I am. I upgraded my mount to an Orion Atlas Pro, and there's my old William Optics refractor, and there I am at GSSP in 2019. And so after a while, I figured out how to start taking these pictures, but it wasn't an easy road to get started, that's for sure. So anyway, that's sort of my background. Oh, and I should mention that, and then once I did that, well, I knew I would be retiring in less than a year at that point. In fact, I retired in January 2020. And so, and I knew I'd need to keep my hands busy with software and fiddling around with stuff. And I found this thing called KStars. I had to select a program to image with, and KStars was interesting for me because you could do it on a Mac or on Linux, and I wasn't a Windows guy. And I could contribute to it. I could change it. And, something was broken, I could fix it. That was something I was interested in. So, in fact, at the end of 29, no, in fact, in August 2019, I started contributing to KStars. And I've done many changes to KStars. In fact, I just looked it up. I put in more than 500 merge requests, pull requests, whatever their source control system that they were using at the time called them. But I made many changes to the system over the years. I'm not the maintainer of it, but I know it pretty well as a developer, and also as a user. I've been using it since then. So I thought I would talk about KStars since it isn't that widely used around here anyway. It is. So what is KStars? KStars, and I'm going to demonstrate it for you guys, is a planetarium program that got started in the early 2000s by a guy named Jason Harris. And it's basically just modeling the sky, showing you how different objects move around where they are at different times, and you can explore the sky. But in the early 2010s, Jason, who I never met, by the way, handed it off to a guy named Jossam Mutlaq. And Jossam is the current maintainer of KStars and ECOS and Indy, and I'll talk about the differences. And what Jossam did is he introduced telescope control, imaging, the ability to image with KStars. And so, when you think of KStars, there's really three names. KStars is the overall program. ECOS is the imaging part of it. And Indy is a separate library and program that deal with controlling devices. So it's sort of the in the PC world, ASCOM, and in the and for this world, it's called Indy, and it's the device drivers and how you actually control physical things like that. And I'm going to talk about, in addition to, I mentioned the planetarium and, managing, taking pictures. There's some tools. You can view pictures. You can plan what you want to image, and you can plan what you want to. You can use this also as an observer to help you plan your observing session. It runs on all platforms pretty much, Linux or Raspberry Pi or Mac or Windows. It's free and open source. You can look at all the source. It is bundled for a few products, so it comes with, for instance, Jossam is the guy that sells StellarMate, which includes KStars. But you can get and run easily KStars for free without StellarMate. It's nice that it supports many languages, so the UI can be in Italian or English or Russian or Hebrew or Arabic or French or you name it. I'll go through that. It's a KDE project. What that means is KDE, for those of you that aren't familiar, is a well, I'll show you what KDE is. Hold on for a second. If I can. Oh no, now I have to find. Did I lose that again? Anyway, I may have, but I may have lost my window. But we could ask AI what KDE is, and you'd find that KDE is a organization that puts out that supports open source projects. It has its main product, or free product, is Plasma, which is a Linux desktop environment, but it supports a whole bunch of projects, and KStars is one of them. In ways like, they provide us servers for our websites, and they do the translation to all the languages, and et cetera, et cetera. As I said, there's a big development team. Well, it's not a big development team. I looked at the number of people since 2020 that have had put in 100 merge requests into KStars, and there's the list. And then there's another bunch of people that have done a little bit less, but still a lot of work in KStars in the last 5 years. There's a forum, indylib.org/forum. This is where you can download KStars. You can get all this information, from your favorite AI or your favorite search engine if you type in download KStars or Indy forum. And there's a manual online. And I'll tell you what, though, even if I can't find it, I'm gonna interrupt this and bring up a couple of those things. So let's say here's the KStars, it's GitLab instead of GitHub, but here's all the sources here. There's a README file and stuff. When people are making changes, these are where the draft changes that haven't gone in yet are. As I said, if you wanted to download KStars, there you go. You go to this KDE page, and you can download it like that. And I did want to do the handbook. I have a bookmark for that. And the reason I wanted to show that is this. So you could see the handbook is available in all those languages. And, that's thanks to KDE. I code UI and I add things to the handbook, but I don't speak any of those except for English. I couldn't do any of that. I write it in English and code the UI in English, and, just following certain conventions, magically, all this stuff gets translated to those languages. So that's very nice. And the forum, if you go, so it's called IndyLib Forum, but many of the posts come about KStars. Like all forums, most posts are about things that maybe aren't working, or at least the person can't get working. But it's an active forum, and there it is. So I'll go back. Okay, so let's see, where am I now? Oh yeah, so I mentioned that I started contributing to KStars, and then what happened was in July 2021, Bruce Bronstein was running this the SJAA imaging special interest group, which had been for until COVID started a um, a live in-person small meeting at the park where SJAA holds events in San Jose. But of course, when COVID happened, it moved to um, Zoom, and so about a year after Zoom started, Bruce decided to move and hand off his organizing this. And he asked me if I would organize it, and I accepted. And so I've been organizing this, and I sort of changed it to a talk series and only over Zoom. I know COVID, the restrictions ended, but I found that we got bigger crowds, honestly, online. And I can get speakers from far away instead of, requiring people to be in San Jose. So I've, on my watch at least, moved it to a talk series over Zoom. And this is the 50th presentation um, in 52 months. This is the 52nd month and the 50th presentation. So somehow, I don't know how, I've managed to get speakers for these 50 months. And of course, that's my pitch. You probably hear it every time I send an email, but we need speakers. I have one definite speaker for sure in December. At this point, that's it. So we need speakers in December. We'll have somebody talking about Nina to complement this KStars talk, I suppose. But it won't happen without people volunteering to talk. And with that, I want to get into KStars. So I've mentioned what it is, and now I'm going to go to the program. And I had hoped to give, sort of a live imaging demonstration as well as just walk you around the program. But honestly, unfortunately, of course, tonight that's not going to happen. The weather just isn't accommodating. So this what you're seeing here, though, is KStars running on my telescope. Just the telescope is covered with you know, it's covered up, so it doesn't get wet. But anyway, here's I mentioned that KStars is a planetarium program, and so here's the planetarium. Now, what you're also seeing is an overlay of my backyard, since the telescope is in my backyard. And if I get rid of the overlay, there's the planetarium. But of course, this circle is, of course, the horizon. You can actually see the sun beyond the horizon and so on in this view. But I'm going to pop back to showing the view that's, for me more interesting because, I can't image stuff that's behind my house or behind that tree or whatever. So for me, this is the view I look at. So what can we do well, let me show you that there's a configuration page here. That, like a lot of these programs, there's a lot of parameters. You can turn on and off star catalogs. Well, we won't see stars on this if we turn off the star catalogs. I have the deep sky catalogs turned off for reasons we can discuss. there's how you display planets, and the sun and the moon, for instance, are displayed at large scales, 8 times larger than they really are, but everything else is displayed to scale, and so on and so forth. And you see satellites, you can see, or at least find them on your telescope, and supernovae. You can put guides in the sky, and so on and so forth. An interesting thing, oh, the terrain is what I showed you, my house. An interesting thing is image overlays. You can put on the sky map pictures of things you've imaged. So I don't know, I don't remember what Able 21, there's Able 2151. Let me stop the clock, um, zoom in a little bit. So that's a picture I made, and it's, placed in the sky where it is right now. So that's one aspect of the sky map. Let's see what else we got. You can find objects. Let me do that. First, I got to find my mouse. So if I use this find button, we can, click in here. Let's say I wanted to find NGC 891. There it is. And, well, it found it. I guess I got to zoom in. Oh, there it is behind that tree. Maybe not the best choice, but let me get rid uh, of the terrain. And there it is. In fact, it's showing you my picture of 891 there, but we can remove my image overlay, and well, it doesn't. Let's see. I think I have to turn on
Yeah.
the catalog, the deep sky thing, and there's, the default image of 891 that comes with KStars. Um, but I like to keep that off because it just puts a lot of boxes everywhere. So let me put my overlays back, um, and continue. So you can find things. An interesting part of if we show, oh yeah, the overlays again, not the overlays, the horizon, um, is that you can, given that you have a picture like this, and it's actually pretty easy to make a picture like this, a 360 sort of spherical picture with, there's various free tools out there to do that. If you do that, then it's sort of easy to trace it. And as you could see here, I have this trace of my, the real horizon for my telescope, and you can tell the system when it's planning things, don't shoot below that, and stuff like that, um, and so on and so forth. So I'll get rid of that. And oh, another interesting thing about KStars is it has this ability in the view HIPS all sky survey. You can show the dark sky survey. So these are professional, all sky images. So, well, here, for instance, when we zoom into the elephant trunk here, you can see my picture, but behind my picture, I'll get rid of my picture for a second, which I believe is this keyboard shortcut. And you can see here's a deep sky survey view of the elephant trunk, aligned right with my image of the elephant trunk. So there's that. You can, do this sky simulation. You can change the time. It's already set to now, but you could set the time to a different day, a different time, and so on and so forth. If you want to see what's in the sky at different times, you can find comets. So I believe, let's see here. we search for, see, 2025 A6, this guy's in the sky, I believe, over there, behind. Again, I have to get rid of my horizon. It's not high up enough. And there it is. I guess not a, it's showing you a small tail, if no tail at all. But anyway, that's where it is. If you wanted to try to image it, you could work that in to the imaging program, as I'll describe later. All right, so that's sort of my story about the sky map. I don't think Akarsh is, Akarsh is online right now, and he's the expert in KStars catalog. So if you have any questions, ask Akarsh, or if you ask me a question, I'm going to defer. But Akash, I believe, put a lot of these things together and may be working on putting the Gaia catalog into KStars.
In due course of time.
In the due course of time. Thank you, Akash. So, Akash, believe it or not, began long, long ago as an intern, I guess, a summer of coder, way back when, right? All right. So something I contributed to KStars that I wanted to show off before I get into the imaging control is the imaging planner. So I'm going to try to bring that up. And there it is. Well, it's getting its act together. And now here it is. And the imaging planner, let me make it a little smaller, comes with a catalog, and it's designed to, where people can add their own catalogs, or this catalog can be updated. And it comes with a catalog of objects that I put together. Basically popular targets in Astrobin, honestly. And there's, as you can see here, 770 of them being shown. And right now, it's showing you, for all these targets, you have an image over here. So, like if you are interested in, imaging something, you can sort of see what other people have done with it. These are all reasonably good quality images. And it's sorted right. You can sort by a number of ways, but I'll make this wider so you could see some other things. It tells you the constellation, what type of object is. The size isn't always accurate. The current, or maybe that's the peak altitude tonight, I believe, at how far it is away from the moon, probably at its closest. I don't remember. But this is an interesting field. This tells you how many hours tonight you could image this object given some other constraints. So you could see here, so if let's say, just do Able 81, you could see this is its altitude graph tonight. So for instance, at 8 p.m., it's around 45 degrees. And it, let's see, we've said minimum altitude 30 degrees here, and to use my artificial horizon. So it satisfies those two constraints. If you were saying, no, I don't like to image, lower than 50, then it as you could see, things changed, right? Nothing is more than 7 hours and so on. But anyway, I'm going to put that 30. And so you can go through and decide on, what suits you, what suits your telescope. Oh, I'll tell you some other things. So here's Able 81, which I just picked. Well, I'll tell you what, let's look at, since I had this planned and I don't remember why, but we can sort we can sort alphabetically too. And so let's say we wanted to do ARP 213, which is this interesting galaxy here. So you can click on the Astrobin link here, And if you do that, it's going to do an astrobin search, bring up a browser, and find a whole bunch of astrobin pictures of the target you searched for. And there you go. And so that's ARP 13. Um, we could pick one of them. Let's pick that one and, check it out. An interesting thing that I don't know if this will apply to ARP 213 or not, but we're going to find out, is I'll show you as follows. So you can, it requires a little messing with the screen, but I have an option here to screenshot some image of ARP 13, plate solve it, and temporarily place it on the sky map. So if I did that, I get a new cursor. I decide this is what I want to screenshot. And there it goes. It could do it automatically, but I'm having it stop so that it can, whoa, where'd it go? And it should be on here. Let me find it. Hmm. Uh-huh. And again, I have to get rid of my terrain. And so this is the screenshot we just took from AstroBin. And what you could see here is a simulation of my RC's field of view. So I can, you know, let's say I decide that's a nice way to image it, in my telescope. I can do that. And now this center coordinate, which I can later use, I'll just jump for a second to our scheduler here. If I hit this button now, it'll put that coordinate in the coordinates field, and that's how I might set up imaging that target. So anyway, there you go. That's one way you can use the planner. Other things you can do to the planner are you can, let's say, oh, you can filter. You don't have to look at all 700 at a time. You could say, I'm just interested in galaxies and remove a bunch of stuff. And now all that's being displayed are, what galaxies I could image now, or, nebula or globulars, or what you like. And I don't know. Oh yeah, the last thing I'll mention is you can select these. The ones in green are ones that I've already imaged, right? So I could say, don't show me things that I've imaged, and then those go away. You can pick certain, let's assume for a second that I decided, I went through the pictures and I decided these were interesting objects. I have my list of things that I've picked, and then I could just view pick objects. I must have had some others already in there, and this is a collection. So you might, do this to narrow down what you want to image, or this might be your list of things to image for the next month or whatever. But anyway, that's an idea of how the imaging planner works. So I showed you the sky map. I showed you the imaging planner, and now I think it might make sense to show you sort of how you image with KStars. As I said, we're not going to um, actually image because of the weather, but I can walk you through a lot. So this is the page. Oh yeah. So I wanted to mention that in KStars you set up a profile. You only do this, when you're setting up your equipment. You don't do this every night. And so, you set which drivers you need. And I have a mount driver. I have a focuser driver, two cameras, a imager and a guider, and a filter driver, and a watchdog that, if bad things happen, will park the mount. So you have to set stuff like that up. But given that I have a profile set up, you can tell KStars to connect, and poof, it's just now connected to all my equipment. This is an indie window, like I say, uh, similar to what you'd have on Windows with, I'm spacing its name. But anyway, it gives you details, but you don't really need to access it much when you're imaging, but give you details about my mount and how I'm connecting to it and so on and so forth. But I can get rid of that window, and let's go to a few pages. So here's the capture page. Um, and in the capture page, by the way, there's something called a optical train, which says when I'm going to be capturing, this is the mount I'm using, this is the camera I'm using, this is the telescope, filter and focuser. I don't have a rotator and so on. I don't have a dust cap, and it can manage these devices. And you could have different optical trains. For instance, there's a different optical train related to guiding, which uses a different camera and could have a different telescope, although in my case I'm guiding through my main telescope. Anyway, so oh, where is lost my KStars? There it is. So here is the capture screen, and you can do things like set an exposure and a filter, gain, and so on and so forth. The file, this tells you the file format of how the files are going to be saved. But I rarely do that, honestly. I've got these things stored on disk. I've got prototypes for these things. And so, for instance, if I were doing RGB 4-minute exposures, I just load that file, and that sets it up for doing about a half hour of red, a half hour of green, and a half hour of blue. And as you'll see later in the scheduler, I can tell it to repeat that any number of times. So that's more or less how you control guiding, capturing. There's, details like, oh, I don't know, this one, refocus every 60 minutes, or refocus if the temperature changes, or don't start your capture if you have bad guiding right now, and how often you dither. And so, anyway, you get the idea. So that's capturing. We don't need to go through all the details. We have a guider um, that does multi-star guiding with many options. You can find here, the normal kind of, guiding algorithms, a few of them, and, the normal kind of aggression and things like that. Dithering, calibration, and this thing deals with this is a Gaussian process guider that this guy, oh, I forget his name, Mac. Anyway, somebody else wrote and open sourced. It has a different name on PhD2. Oh, I should mention you don't have to use the KStars guider. You could use the PhD2 guider if you so choose. Anyway, it has full, fledged guiding and plate solving. You can use a number of different plate solvers. In this case, I'm using the internal one, but you could use ASTAP, Watney. You could go online, but that's really slow, and so on. So I've already showed you a little bit of plate solving when I did that demo of the planner. So you can do that. The alignment also does polar alignment, and it does it anywhere in the sky. So it'll take 3 pictures, figure out your error, and then this is hard to show detail of here, but it would show you what direction to move the azimuth and the pitch of the telescope in order to correct your polar alignment. And similar, there's a focus tab, and there's a mount tab, which isn't used that much. This is effectively a hand control. But what I wanted to show at this point was the scheduler, which also I've contributed a bunch to. And an interesting way to show the scheduler is to bring up sort of a ridiculous schedule. So I put together a schedule, uh, an imaginary schedule for imaging tonight of several jobs, just to show you what the scheduler does. Um, and then I'll show you, like what I might really do tonight. But so you could see this has, a job starting. Um, let's see here. What is this job? Well, I'd be able to find out by clicking this. See, Able 426 is the highest priority job, but it's too low to start until this time, 10:18. So even though it's the highest priority one, some other jobs are going to start earlier. And it turns out it's this 7129 job, which runs until it runs here. And you could see here 7129 is set to run till sequence completion. And it was using that hour and a half capture file that I discussed earlier. So it just finishes in an hour and a half and it completes, and then another job takes over at this point at around 10 o'clock. And what is that? It's this one, IC59, which is a relatively low priority job in this stack. And that runs until a higher priority job here. Our friend Able 426 is ready to roll. So it will get interrupted. So this just basically, you get the idea, shows you the plan for the night. You can change the priority of things just by moving these things down. And you can see that as we move the priority of 426 down, it gets delayed later and later at night until other things have completed or no longer satisfy their constraints. And you can do that while things are running. You can edit these jobs while things are running, and it should all work well. So I'll show you what I really do. I mean, I typically, since I image from light polluted, Silicon Valley, I don't, nothing is gonna be shot in an hour and a half unless it's some kind of comet or something like that. So so basically, I'm gonna have one or two jobs a night, and I will load. Let's see what the last one I had there, which is Able 2634, which is in the sky a lot tonight until, it gets too low at around 3 a.m. And, maybe I'd add another job to image after it's done putting that lower priority. But anyway, that's more or less you set up your schedule, and then each job, as I say, has these constraints, altitude, moon, horizon, but the one you really use is, completion, repeat the schedule for so many times. And you just click start. And then I go inside. I never go outside. I mean, I go outside to uncover it, but then there I am inside. I click play and then turn on the TV and, watch the Warriors. Wake up in the morning and hopefully it's done. And I'll give you an idea with this other window that I wrote called the Analyze window. And what it does is it gives you a summary of what happened last night, or it's actually ongoing. So what happened so far tonight? And in this case, we're looking back at September 26th, last time I imaged, I guess. And it shows you what happened all night. And you can see that, it took some red, some green, some blue, some L exposures, and then went back to, repeated and repeated. You can see graphs of the guiding. You could see graphs of the H of R, the different frames, or which is the blue, I believe. I'll blink that on and off. You can see the sky conditions, which is uh, anyway, that's the number of stars that were detected in the frame. Let's see, is this? Oh, the SNR, that's the one, that's this yellow line, which I typically use. That's the guiding SNR. Looking at the difference between the guide stars and the background, the sky background. So anyway, there you have it. You can play with these scales and see it. Oh, and one other cool thing you can do is you can, look at individual exposures. I double clicked on that, and there's a particular image. There's one more thing I guess I could show you with KStars, but before I do want to ask if there's any questions or anything like that before I continue on. I know I've been talking nonstop for quite a while.
I thought I saw an option for image integration. Is that something still in development, or does that actually build your image in front of you?
All right, well, I'm glad you asked that because that's the if there's no other questions, I will go to that. But that was the next thing I was going to talk about. Okay, so I didn't hear anything else, so I'll go on to the next thing. So when you ask about image integration, it's not going to, KStars isn't PixInsight. It's not going to do that, but we do have a live stacking option. So I'll show you that. So under the file menu there, and that was the last demo that I was going to do for KStars. And up, sometimes up pops there it is, a window of a live stacker. So I showed you one Able 2634 sub, right? Which is, I forget what it was. I guess I could see right here. It's an 2-minute L sub of this Galaxy cluster. But we do have live stacking, and that can run while you're imaging, and it can monitor a folder, and as images get put in the folder, stack them, and give you an idea of what your final integration might look like. I assume that's the question you're asking. So let me do that. So I'm going to go to where my images are stored. And I'm just gonna, I have the different filters in different folders, and I'm just going to stack the L images. And when I hit start, it's gonna start doing that. Now I got a lot of images. In fact, let me see if I can find, if we look, before I do that, here's 2634. And if I mouse over captures, yeah, there it is. You can see I already have 600 which is 20 hours of that, which is sort of typical for me. I might go to 30 hours of that. So I have a lot of them, but you can sort of see, it'll show you over here how many images it's used for its stack. So it's going to stack everything in this directory. There's 600 files there. And if you want, you can give it calibration files, a master dark and a flat, to use for its stacking, and then you could just tell it to start. And there it goes. And so that's 5, that's 13, as maybe you can see that number over here incrementing, and the picture is getting clearer and clearer. It's not doing any like that satellite streak that'll sort of fade out as we get more images. It's not doing anything to get rid of those pixels, just because that's pretty slow, and our intention is to make this a fast process. But you could see the difference here we are with at 120 images versus, a single sub, right? Big difference. Let me get rid of that so that they're the same size. And let's do it this way so they'll be both the same size. And there you go, right? You can see this nice galaxy here, these galaxies, when you stack these images that you don't see out of the single sub. So that's the answer, Chris, to what we do in terms of image integration. John Evans is a contributor to KStars from Wales. Put that together, I don't know, in the last year. He did a fantastic job with that. So there you have it. I guess there's one other thing that's interesting that reminds me that John actually did too. That's interesting. Maybe let me stop this. Where is it? Oh, it's going to be in here. Well, I'll do it in this image for now. I don't know how it interacts with stacking, but there's this thing called catalog objects. And when you look at a FITS file, you can click this I symbol here, and it defaults to a small part of the image. But if I put a circle right there, it went out to Simbad and queried those coordinates for objects in that area. And anyway, so you can do that and look at the various objects. There's filters, so I guess I could check all and do that again because I don't know what I had filtered originally. If you 1 second, hold on. Anyway, so there you go, and we can, click on them, and you could see what you have. Whoops, what you have in your image, and get more detail from Simbad. Anyway, so that's one more thing you can do with KStars. So let me get rid of that. I've done that. So that's pretty much the tour that I had planned, and that's about an hour. So I'm going to, since I really can't see anybody, stop sharing, hopefully find my, yeah, here it is, my Zoom window, and ask if there are any other questions that anybody has. Whoop, I lost it. I see there's 4 messages, but I'm having trouble getting them. Oh, I see.
I wouldn't say there are questions. There's a
Oh,
comment about the future version not running on ARM64. But I see that Akash already replied.
Oh, well,
I
know you
sorry,
can
I'll
run.
let Hyle.
I know you can run KStars on ARM because I do it.
Yeah, and the Rosetta 2 shouldn't be in the picture if it's compiled for ARM64.
Yes, but it's not. It's x86 64, and Rosetta 2 should kick in and translate it. And it did for 378, but it doesn't appear to be working for 379.
Okay, so there may be, I don't know if there's something happened for that particular 379 just came out, right? Like in the last week. So I don't know what the status is. But in general, KStars runs on Apple Silicon. I don't think KStars is compiled for Apple Silicon.
No, it's not. It's interpreted by the Rosetta x86 interpreter, which automatically should be invoked the first time you initiate an x86 application on Mac. And it worked for me on 378, but it's not currently working for me now in 379.
So, can you send me an email and I'll forward it to the guy, who does
Sure.
that?
Yep,
And
will
I
do.
can put you guys in touch and, if there's a problem with that. I know that, I mean, they released 379 literally in the last few days, right? So,
But it's can it be compiled for ARM, or the toolchain is only generates x86 code?
well, I mean, why couldn't it be compiled for ARM, right? The question is just somebody's got to get his, just do it, right? I mean, and he's busy doing,
Yeah.
teaching high school, I mean, it's just that simple, right? It's just a question of volunteers doing that. And, given that they have a working version, for the
Yeah.
x86, I think that's where it stands. But, he's been talking about doing that for a while, so hopefully it'll happen. But,
Well, they've been talking about doing
Just
that for Pix Insight as well. So
okay. Yeah, and if
yeah,
anybody,
I don't think that
go ahead.
preventing running on Apple Silicon. I just remember that the tool chain for Mac builds is really complicated because it has to port all the dependencies that we rely on, which are very naturally built for Linux. And I remember running the tool chain once. There's exactly one person in our core developer group who actively tests on Mac. And I don't think we have anyone who actively tests on Windows. So Windows might be a little more broken, but we have somebody that regularly tests on Mac, and I think the toolchain probably supports ARM64. I've only compiled it on Intel Mac, so
I'm pretty sure Windows works. I mean, JASM definitely makes sure that it works on Windows.
Also famously runs
oh, I didn't.
on Pi, right? Raspberry Pi.
Yeah, well, Pi Linux, right,
Pi is ARM, so
right. No, there's nothing about ARM. It's just the like Aker said, the tool chain
Yep.
for Mac is one guy who, has a day job.
Yep.
What can you do? It would be great if somebody at Apple, loved KStars.
we can't.
I don't mean you necessarily.
Apple doesn't. Yeah, Apple has very strict rules on open source contribution.
Yep.
I had to get special permission. So
Yeah.
Hi, I have a question. Is it does KStars, or more properly ECOS, I guess, support some form of extension via plugins, or the extension model is that you make a PR and gets embedded into the main repository?
So there are a lot of places. So I don't know if you can, like do fundamental changes to the capture module, like there's something you don't like about it, and but there are many places to add scripts, before you start a job, before you capture things like that. I may be misquoting them because I never used that, but there are many places that scripts can be added, and people do that. And that's different, I know, than what you're asking, but I just thought it's related. So, a lot of people use that for like controlling their observatory, right? Their domes and their whatever, or special equipment. And then there was one other thing that just got added that I'm not that familiar with, related to that. But anyway, it's in that flavor of hooks for scripts.
Yep.
I don't think people do that much, of what you're talking about, plugins like Nina. All right. Any other questions? All right. Well,
wasn't there a PR?
Oh, go ahead.
Yeah, wasn't there a PR many weeks ago or many months ago that added plugins? Was that for the ECOS capture plugin or something?
Is
that what?
I don't remember. Yeah, there was something, and you're right, and I didn't want to talk about it because I don't know, I'm not familiar with it, and I
No,
didn't
the
want
state
to
of
say
freedom.
something wrong. Here, there was something related to that, but I honestly, it isn't a full plug-in mechanism. I know that, but
That's what I also got, not a full plug-in mechanism.
anyway, so I can't comment about it because I don't remember, and I'd mess it up if I tried to wing it.
Yeah, same here. I don't remember that, but I just remember there's somebody trying to work on it.
Right. Agreed. All right. Well, like I said, in a couple of months, we'll have a talk about Nina, and hopefully we'll have other talks. So please volunteer. And until then, thanks very much for attending, and I'll see everybody next month.
Well, I guess that you are not going to do it tonight, so I'm going to do it, and to call everybody to give a round of applause to the presentation.
Okay. Thank you. All right. See everyone.
Good job, Hi.
Thanks.
Good job. Yep. Thank you.
Thank you.
Bye.